Thank you, Marianne, and thank you to the PyData team and the organizers for having me here. It's a great pleasure. Indeed, my name is Tiran-Cappello. I work as a data scientist, now MLOps engineer at Renault Digital, where I maintain the MLOps pipeline for the data lake. And I also animate best practice session 2 times a week with my evil twin. And today I'm going to talk to but I'm only saying this because even though I'm not here as a part of a Renault group today, I'm only saying this because during my day job, I get called quite a bit to debug some pandas code that is either failing or has terrible performance. And a lot of this experience has shaped a lot of yes ideas that will come up during this live coding presentation. I will refrain from swearing and I will keep it very professional, but there might be some decent level of salt at certain times. And I'm here to present to you today Pelage, an open source package that I developed that is used to bring a basic set of practices from software engineering into the world of data science to help you write better data science code with polars and test-driven development, aka TDD. And what is TDD exactly? Quick census first. Who has ever written an automated test in Python? Can I get a quick show of hands? So about 3/4 of the room. Who has done that as writing a test first? About half of the room. And who has done that with pandas? Less than a quarter, even less than a fifth, I would say. Okay, great. So to give you a good idea, for those who don't know, test-driven development is this iterative loop in which you start by writing a failing test, then write a simple amount of code to make the test pass, and then you refactor your code to make it better and more efficient. And this is a loop and a process that will see countless time during this presentation, but before we can dive right into the TDD part, I'd like to bring everyone through a journey where we're going to take some pandas code, translate it into polars so that everyone can get accustomed to polar syntax and specificities. And in a second time, we will bring polars and Pelage together to write data tests first, see them fail, write some code, and then make the test pass. So let's first start with the actual live coding where everything can go wrong. Let's not, okay, seems working, things are working, great. Okay, first, at first glance, what do you think about this pandas code? If you get your gut feeling, is it good, is it bad, is it all right? Just get a feeling. Who think it's bad? Just few person. Who think it's okay? About the same. And who thinks it's pretty good? Nobody. Okay. I personally think it's terrible and I should never been written because I wrote it. And the first element that can point in that direction is the absence of formatting, but that's actually minimal. The thing that is for me a killer is the use of for loops with pandas. Here, basically iterating over a column of data frame to filter, and then do some aggregation, which is basically a group by in disguise. And unless you want to, this is really something that kills performance and something that I debug all the time in production, so especially for senior data scientists in big consulting groups that do that and then complain that even the largest machine on GCP doesn't make the code run for some reason. Anyway, so please don't use for loops, be awesome. I know you can do it. So we're going to start fairly quickly. Sorry, what's happening in here? I just need, can I get here? Up. Let me just, all right. So we're going to start with the oldest trick in the book of the world of test. We're going to start with an equivalence test. We're going to do PD, testing, up, assert from equal. And we are going to use the old df and the group df. Okay, I'm just going to obviously need to do a little bit of reset index because this is pandas and this is troublesome. So true. Okay, And first, I get some kind of my executions working, which is great. We also have a bit of fair amount of warning, which is usually a good indication also that the code is not very good. And once my first test has run, everything's running, I get rid of the equivalence and I get ready for the refactoring. So first, we're going to take care of these for loops. And the things that I'm going to stress out during this presentation will be the continuous use of method chaining in pandas to do the transformation. So we are going to do that. So we're going to first group by, that will be manufacturer name. We have the year then. There will be after that some ACK function. And because we have manufacturer name in here, in the results, that means we need also a reset index in here. Okay, which means now I can get rid of all this junk and get just the aggregation and put it here. And now I can actually use the keyword syntax in the aggregation function to just say, okay, I'm going to take my columns. There will be in the second part of the tuple, the aggregation function itself. And now everything should still work, except I'm missing a little bit here. It's fine. Unique. And everything should still work. Perfect. I can further drop things because they were just here to deal with the for loop shenanigans and still looking good. Okay, now I will continue to do as much chaining as I can do in order to get rid of all those intermediate assignments if I can. So putting here, so more chaining here. Same thing for the, there's probably something missing. Oh, there's something that's supposed to be here. Sorry, let's fix that. And same for the drop NA and drop, where you see this use of in place is equal true, which is usually a killer as well for performance and maintainability. They don't do anything to save memory, so just get rid of those and continue your chaining operations. That will be so much nicer. I promise you at the end. So, all right. So this is starting to look pretty good, but this is not over yet. We have still to take care of the filtering and column creation and modification. For the filtering, it's actually fairly easy because the square brackets here is akin to a lock call. And inside the lock, you can actually reference the current data frame using a lambda. So just saying, when you see a lambda in pandas, you think, oh, get my current data frame in here, get the column vehicle count, it must be above 100. And nice, I don't need those intermediate names anymore. I can just continue my chaining and everything's working. Same in here with the column modification, I can just use the assign method and I'm going to use the same trick. So here, bring this. So the column fuel consumption will be basically created with a lambda to get the current column. Up. Need a comma at the end. Still executing, still working. Okay. And now the same type for the same thing for the fuel type column. Fuel type it becomes from lambda. Lambda we say stand is moving. df fuel type, and we are going to replace. Sorry, the stance is moving a bit, so it's I'm a little shaky.
Don't replace.
Yeah, thank you. Petrol with petrol. Okay, and indeed, thank you, Marianne, for the dot replace. Okay, and oh no, missed something. Okay, all right. Let's finish this quickly. Fuel type should be equal a lambda df the fuel type. All right. Now we should be back on track. Okay, still working. And actually, I can get rid of this now. Fuel type. Yep. All right, this is still working. Why is it still working? It should not be working. This? Okay, now it's working. Weird. Oops, something. And so now I can actually get rid of all those intermediate variables anymore because they don't serve any purpose at all. So I'm just going to continue these transformations and basically have a fixed set and I can give it a meaningful name that will be yearly consumption. Something like that. And all right, so now that we have seen, we can, by refactoring some, by using some pandas code with method chaining, we will be able to actually translate that fairly easily to polars. The first thing we are going to do is import our test. So from polars import testing. Okay, and I'm just going to shift my test. We don't need the reset index anymore. And this is going to be transformed into a PL data frame in here. Okay, and this, almost working.
Import polars as PL.
Excuse me?
Import polars as PL.
Should be, oh no, of course, I forgot to transform my data frame into a polar data frame. There we go. And it works. Okay, so back on track. Okay. Now, what I need to translate that, I just need to shift this thing up and fix the error. So shift it up, there is no index in polars. Shift it up, lock becomes filter. And whenever you see a lambda expression in good written pandas, you substitute with pl.call expression, and it will work. Run, still working. Shift this up, sort values becomes sort, and ascending becomes descending. This should fail. And if I flip the Boolean, it works. Again, I'm going to shift things up. Group by will get an underscore and becomes pipette compliant. Thank you for syntax highlighting. I don't need reset index, no index in polars. And I can just, again, select a current column of my data frame with pl.call expression. And here I just need to chain the transformation with polars expression. Fix just with underscores. Up, there we go. And it should almost work. There is a slight type mismatch that we are going to fix right away, which will be here. So cast pl int 64, and we are good to go. Back on track. Okay, we continue. We shift this up. Assign becomes with columns. Again, we have lambdas. They are replaced by pl.call expression, and here I'm just going to fix this briefly. Up, and this should still work. Okay, shift it up, drop as no access, still working, and finally, take care of drop NA, that becomes drop nulls. And everything is working. I'm going to skip the fixing of the constructor here, but you see that by using method chaining, it becomes fairly easy to refactor, to translate pandas into polars. And, but we have not seen the TDD part yet. We have only used equivalence testing. So what about the TDD part? And who is this guy that has come up so many times during this presentation? This is Ken Beck. He's the guy who coined the term TDD, and he created one of the very first testing frameworks called SUnit. And he found that usually it's a good idea to have a testing framework to be expressed in the very same language as the code you're currently writing. This is really what enables TDD. And by doing that, you're able to actually reduce developer anxiety, which is something that I feel quite a bit right now. And so I need a lot of TDD. And Ken Beck usually has a good set of ideas about software development. This is where Pelage enters the scene. It's a testing framework, as I mentioned, to help data scientists. And it behaves simply by passing a data frame to a test function. If it fails, you get a nice descriptive error message, and if it works, you get your data frame back and you can continue working on it. All right, so now let's dive into the TDD part. So we're going to get the same data frame we have been working on with so far, emission with TDD. So it's a data set with carbon emissions for electric vehicles in Europe. And I'm going to start by doing import Pelage as a PLG. Okay, and then I'm going to apply a test to my data frame. For instance, I'm going to check whether the mass is within well-defined boundaries. So I'm going to pipe PLG accepted range for the column mass mass in kilograms to be between 1,000 kilos and 2,000 kilograms. Oh no, my test fails. What a shocker. There are masses above 2,000 kilograms. Okay, let's write the smallest amount of code to make the test pass. The test passes, great. Okay, but you know I did something very stupid, but I actually wrote down the specification of my data frame within my code, and they are now embedded within my analysis. So I can continue. Oh, this looks like a Boolean colon encoded as 0 and 1. I don't like this, so let's change this. Pipe, PLG, as dtypes, we will check of the colon used in calculation, and it should be of type PL Boolean. Up, there we go. Oh no, my test fails. Okay, I'm going to write a simple amount of code to make it pass. So cast this, and now my test passes. Great. Okay, I'm a software engineer. Wonderful. Okay, I can continue. Let's look at all these categorical columns. I don't like when there are nulls within my categorical columns. So by PLG as no nulls. I'm going to pass the whole list. Okay, and beep, beep, boop. Don't need that. Okay. And what a shocker, there are nulls in my data frame. Who would have believed? Okay, I have about 1 million rows, so 3 nulls here, not a big deal. Commercial name might be a little bit more of an issue. So let's put the commercial name on the side for now, and I'm going to write the simple amount of code to make my test pass. So, drop nulls, let's say subset, and we pass the list, format everything automatically, and okay, my test passes. Okay, now let's make sure that we don't have any bad manufacturer that produce a lot of cars with a weird commercial name. So we are going to write a test for that. We are going to check that the null proportion for commercial names, commercial name should be between, let's say, 0.98 and 1, so 2% maximum null value authorized. And interestingly, this passes. But what if I had a group by manufacturer name? Oh no, we have at least a couple constructors, couple manufacturers with a lot of nulls in their commercial names. Oh, okay, that's actually interesting. I might need to take a note of that. Okay, and I just did. Okay, then I can continue. Let's look at the primary keys of our data sets briefly. So I can obviously the features of a primary key, it should be not null, which we just checked. And they must be also unique. So we are going to check that. So their combination must be unique, and we have a function, unique combination of column. Primary key, okay. And indeed, we have a lot of errors because some vehicles, per combination of primary keys, we have a lot of, duplications. So let's get rid of those. We'll start by, we're going to do something very simple. Let's do just a group by primary key columns. We're going to take the last element so that we don't suppress anything. This is a little hard, but it's working. Okay. And now I can continue working. And for instance, let's have a look at this column, fuel type, that we have been working with so far. We actually see a lot of mixture between uppercase and lowercase. Let's write a test to make everything nice and tidy. So we are going to write a custom check in which we are going to tell the colon fuel type, fuel type, str contains, and we are going to use a regex to select only uppercase, and it should not have any of those. Okay, test failing as expected, and now I'm just going to write the most idiotic code that I can to make it pass. I'm going to write pl call fuel type str lowercase, and my test passes. Okay, 5 minutes, perfect, thank you, I'm on time, great. Okay, now let's continue. Actually, let's continue our analysis with the colon fuel type. So we are going to do get colon fuel type, and we are going to count our values. Up, value counts. Thank you, VS Code. Okay, and you see here we have petrol and diesel, which is kind of weird for electric cars. So that sounds like some nasty things that we don't want to have to deal with in our data set. So we're going to, surprisingly, write a test for that. PLG, not accepted values in the colon fuel type. Oop. Should be this list. So diesel and petrol. Okay. And obviously it fails. And now I'm just going to take that and say, well, I'd like, if you please, to have a the colon fuel type to not be in this list. We don't want that at all. And there we go. And you can see that I can now just change the orders of my transformation and see if the transformation still fit the assumption that I written down in my code. And here, because I'm changing the filter before I modify the fuel type column, it doesn't. So I revert, and now I'm still in a working state. Okay, so I've shown you quite a bit of different ways to work with Pelage. There are other features. We have seen some features that can be applied at the level of the data frame, some checks that can be applied at the level of columns, others that can be applied at the level of groups. There are other features for time series and stuff like this. I won't get into the details today. But to conclude and wrap up everything that we have seen so far, we've seen that this part of method chaining is really critical for the data science workflow. It's really easy. It's not easy, but you can get from really slow performing, horrible pandas code with a lot of mutation in between to good, easy to read and replayable pandas code. And then the translation to polars becomes straightforward, really straightforward. You just need a good equivalence test and you shift the constructor up and you're done. And within the TDD, for TDD in data science, so far we are usually lacking a little bit the tools to express the test in the same way as we express the code we write. And and when we get these tools, we're able to get insights about the data set as we build up our analysis and embed that in our code. So, really, this is a critical part of the TDD workflow. Thankfully, in Pelage, it has already been done for you. The core logic just leverages polars. There are just a little bit of Python on the side to basically deal with user input. But the result is something that is simple, lightweight, and fair to use. And this allows you to embed and create good quality from the start in your code as you write your data science project, and with the aim to go into production-like context. So all you have to do is write a failing test, write some code to make it pass, and refactor to make the code better. And now you just type UV add Pelage because it's better than pip. You can go to the website, which is right here, where you have all the introduction, the reference and the documentation for all methods, examples to get you started, and for those who like SQL like I do, there are some nice features as well. And other than that, you have a QR code for the presentation and for my LinkedIn if you want to connect. And from that, I have to thank you for your attention. If there are any questions, feedbacks, comments, or Rotten Tomatoes, I'd like to have them now, please.
Wow, that was impressive. Congrats on the live coding.
Thank you, that was amazing.
And also on developing Pelage, of course. Questions in the room, please. Yep.
Okay, yeah. Firstly, thank you for the great talk and also very vivid live demo. My question would be, because when we write the formal pipeline in the code base, then we will use, for example, the PyTest and then write some tests under the test folder. And based on what you show, it's currently showing how we can use the package inside the notebook environment. So I wonder if it's also possible to use the package Pelage efficiently together with the formal testing.
With formal testing like PyTest, yeah, absolutely. But you could always write, embed all your tests in a function and run that, at the end of your PyTest and of your transformation. I really don't like that approach too much because I really like to keep my tests with the code that basically support the transformation. The easiest way to use that is usually to basically have a data set. You run your data set through your transformation and your tests, and at the end you check the output within PyTest. But you can definitely do that, yes. Actually, this is how I do it, when I test Pelage. I just create some simple data sets, run them through transformation and tests, and make sure that the output is as I expected.
Any other question?
Did you consider making Pelage like a Polars plugin, writing it in Rust, and what are your considerations there?
Yes, I don't have enough experience with Rust yet to be able to do that, but this is something that I think is a nice direction to go into. Although Polars plugin usually don't affect data frame, they are more like expression that you write within the Polars method themselves. So it's not exactly the same case because the test needs to usually to happen at the level of the data frame. So I would need to basically integrate myself probably at the level directly of Polars itself. And then there are all kinds of consideration to deal with basically what you can cache of your transformation, what you can reuse between the different tests that I have not taken into account yet because it's fairly complicated, I would say. But I would love to actually at least use the Polars the Rust version of Polars directly, and to basically to reduce the footprint of the Python code if possible. But that still requires quite a bit of work from my side.
Of course. Any other question in the room?
There is one
Sorry.
question here.
Yeah, so you showed Python code and you compared with DBT.
Yes.
Yeah. So my question is, at which exact step would you recommend running this Python checks? Because running the actual application is maybe a bit too late.
I would recommend whenever you start a data science project, you start with tests. But that's my personal preference and my personal bias. But thank you very much for the question with DBT, because actually the raison d'être from Pelage is actually the experience I had with DBT and some colleague of mine that showed me, oh, I can actually start my data test first. And I'm like, oh, I need the exact same thing in my notebook, because the only thing that I miss with SQL is basically the possibility to do some display and des graphs, like graphs and visualization. And this is why I wrote it, basically because Polar syntax is so close to SQL. I needed something that had a similar taste and feeling as DBT test to be able to, if needed, translate all my Polars code into SQL and have the exact same equivalent. So this is why it's really important for me to start with test from the start, even with DBT or with Polars. It's because then you can move and refactor go from one to the other. For those who are curious, I currently have on screen the difference of speed between the bad Polar code, the bad pandas code, and the good pandas code, and you can say that there is basically a factor 4 between the two of them. And I just add a very simple group by with 2 for loops. So basically, whenever you're using for loops within your pandas code, you're going back to the early 2000s in terms of computer speed. Just
saying.
Just saying.
We're short on time, but if there was one last question, let's take it. Yeah, okay. Lucky you.
Hi, Alex. Thank you for the talk.
Hello.
How does Pelage compare to Great Expectation? Because this is in the same realm of data testing, basically. I know Great Expectation do not support Polars officially, but maybe that's just the difference. But what's your take?
Thank you very much for the question. That is a great question. Great Expectation is a great package, but I come back to this idea of Ken Beck of having the test framework to be in the same language as the code. And when we are writing pandas or Polars, we are not writing Python. We are writing in a specific DSL, a subdomain of Python, which is very specific. And this is why Great Expectation doesn't really work for us, because it's quite a little verbose. It's very much object-oriented. And for us, when we do that transformation, we pay the price of having to adapt Great Expectation to make the workflow as easy as I was able to make it appear. So Great Expectation, great package. There are a lot of other testing framework and data quality framework like PyData that work great, but they are not very well adapted to our purpose and our needs. Thank you very much.
Thank you, everyone. And let's thank our speaker again. That was amazing.